Hello Year 11s, this is a lesson for 14G, so graphs of sine and cosine. So hopefully by the end of all these PowerPoints you'll be able to sort of make sense of it all. Okay, so we start with sine. Okay, sine is represents our vertical component of our unit circle. So if I'm drawing the unit circle up here at the top, okay, so remember that as we go around in a circle, it's not a very good circle, I understand, but with our sine graph, remember our sine represents our vertical component. Okay, so when we start there at 0 degrees, okay, or 0 pi, our height is actually 0, and that's what that location there represents. Okay, when this moves around, okay, it moves around to pi on 2. Okay, pi on 2, that's above there. Its value is 1. Okay, so remember our unit circle, the distance is 1, 1, and 1 as I got there. And that represents that location that's given there. Okay, so that represents pi on 2. So that's the same location. So we're just graphing that vertical component of our unit circle. Okay, as we continue to move around, okay, so as we move around this way, we move towards pi. Okay, pi at that location right there, its height is 0. Okay, and that's what it represents on the graph right there. As we continue to move the way around, you'll be able to see the pattern. Okay. So what we have, that'll be 3 pi on 2. Okay, so 3 pi on 2. That location right there represents as -1. Okay, and that is represented as -1 on our graph. And then as we again finish and work our way around, we get back to 2 pi. Okay, remember that 2 pi is the same as 0. Okay, so that's our initial location. Okay, and that goes back to 0. Okay, because our height, our vertical component in our unit circle is 0. So as you can notice that it sort of flows up, down, up, and what will happen is that will continue to repeat. So that process will repeat forever unless you have a restricted domain, okay, unless we're restricting the domain. Otherwise, that's how our graph sort of works. It links a lot to wavelengths, okay, so if you've seen any wavelengths on some physics or some different subjects that you would have seen over the years, it links a lot with wavelengths, okay? But this is our sine graph. So it starts at 0, goes to 1, then at pi, goes back to 0, 3 pi on 2 goes to -1, and then 2 pi, okay? So that represents our period, okay? So we call that period the time it takes to do one full wavelength, okay? So it sort of goes, time it takes to go up, down, and back up, okay? That's our period. And our amplitude is the height, okay? So our amplitude right there is the height. And it's from the sort of the center where our sine graph balances out, okay? We call it the mean, okay? So where that mean section in the middle of the two, that height is 1, okay? You're obviously going to have questions where that can change, but in this case, that's what the amplitude represents, okay? So from the middle up to the top, okay? So some observations that we can notice, okay? So the graph repeats itself up to pi on 2 units, okay? So that's what we know. So once we had the full revolution, okay, it continued to repeat, okay? The intervals between repetitions is called the period of the function, okay? Also called the wavelength, so what I mentioned before with the period in that green box. In this case, the period is 2 pi units, okay? So this is what we're observing of our standard sine graph, okay? So our period will change. We'll get into a few things like that. There's a few little formulas that we'll need to use, okay? But I'll touch on that a little bit later. The max and min, 1 and -1. So notice that arrow that I drew before was the 1. So as we have our sine graph there, we go up, down, up, okay? That max on our y is 1, and the minimum is -1, okay? Just like what I've drawn there. Okay, and then the distance between the mean position, okay, when we're calling the mean position, I'm talking about that location there, okay, in this case, y equals 0, and the maximum position is called the amplitude, okay, so what I just mentioned before. Now we've got our cosine graph, okay, so as we start with our cosine graph, I'm going to draw it, hopefully it's a little bit better than my last one, okay, so I draw this around, a little bit better, not great, but a little bit better, okay. Cosine represents our horizontal distance, okay? So remember that we're starting at 1, 1, -1, -1, okay? So when we start at our initial location. I'm going to change coloured pens, probably a bit easier so everyone can see. Okay, so when we start to at our original location at 0 degrees, okay, our horizontal distance is actually 1. So at 0 degrees, we should start at 1, and that's what our first location is. So slightly different to the cosine to the sine graph. The sine we started at 0, so the sine we would have started somewhere around there, but in this case we're up the top. Okay, we start at 1. The pattern works exactly the same. So as we rotate to up the top to pi on 2, okay, so as we're at that location, if you notice that we've got no horizontal change, okay, so our horizontal location or our x value is actually 0, okay, and that represents that location there. As we rotate further around, okay, we're going around, we go across to pi, okay, so at pi, our horizontal location is actually -1, okay, so it's -1, which is represented by that location down the bottom. As we continue around, again, there is a big pattern to this, okay, so as we move around to 3 pi on 2, okay, obviously our horizontal distance is 0, apologise for my dog, okay, and then as we rotate around to 2 pi, okay, or 0 degrees, remember they represent the same value, our horizontal distance is 1, okay, so our horizontal distance is that section there, which is what cos represents. That represents as 1. What you find is that's our period. Okay, so our period can be calculated in between 2 points on the same part of the graph. Okay, so notice that this period in this instance is being calculated from the peak to the peak. Okay, I could calculate the period from there to there. Okay, it actually doesn't matter. You're always going to get the same value. What the period represents is the time that it takes to do 1 full revolution. Okay, so as it goes from its starting location and gets back to its original position of what it does. So as we move through the period, it goes down and then up as we move across. Okay, that's our period. Our period is still 2 pi. So the sine and cosine, unless they've been changed, we'll touch on that a little bit later, the period is 2 pi, and that's the base start. And that links into, obviously, 2 pi is 1 full revolution of our unit circle. Okay, and in this case, the amplitude is still 1. Okay, so amplitude is represented by the 1 at the front of the cosine. Remember, there's always a 1 there, which is sometimes lazy to write that, so we just ignore it. Okay, but amplitude is 1, and that's the height from our mean position. Remember, our mean position is when y equals 0. Okay, so it's that horizontal line where the axis is. Okay, so some observations. The period is still 2 pi, and the amplitude is 1. So exactly the same as our sine graph. Okay, that hasn't changed. What has changed is the graph of cos is the graph of sine, translated pi on 2 units in the negative direction. Okay, so what you have is, if I draw my graph here, I've got my sine graph. Okay, that's my sine of x. Okay, what's happened is every single value we're just translating to the left, pi on 2 units. And what that gets us our cos graph. Okay, which sort of works like that. And this is our cos of x. Okay, so that's what's happened. It's just been translated pi on 2 units to the left, and we get the exact same values, the exact same graph. Okay, so how do we sketch these? Okay, what we're going to do is we're going to sketch these graphs with our amplitude, our A at the start, and then we're going to change our period. Okay, so we're going to get a couple of different formulas just to help us draw our graphs. Okay, so some important properties of these values. Okay, a period is calculated by 2 pi divided by n. N is the number in front of the x inside our function. Okay, it's inside our function. Remember, the values inside our function all change our horizontal displacement. Okay, so it might be dilated from the y-axis. Okay, so it could be from the y-axis, or it could be translated left or right in along the x-axis. The value A at the front will change our amplitude, so that'll be our dilation from the x-axis, and as we move through the exercises, you might get something that'll be like plus b, which would represent our vertical translation. Okay, so this is our dilation. Okay, that n represent so that's a dilation, sorry, from x-axis. Okay, and that's represented by the A. Our n is our dilation from the y-axis. Okay. The period is calculated by 2 pi divided by n. So whatever that value of n is, that'll let us know how wide our period is. The amplitude is A, as I spoke about before. The domain is R, so obviously it's never ending, okay? So that pattern is going to constantly repeat itself, okay? So as I draw across here, okay, our sine graph could be up, down, up, down, up, down, up, down, up, down, forever, okay? So it's never actually going to end unless we change the domain. And the range is negative A to A, okay? So it helps us nice and easy. So if our A in this case is 3, okay, the range would be from negative 3 to positive 3, okay? So in this case, it'll be negative 3 and positive 3, okay? So that'll be our range, okay? This graph down here, if I might have to swing my head around, so I might move it to the bottom left-hand corner. Okay, this is what happens when we change our amplitude, okay? So this larger graph, okay, that large one that I'm just sort of highlighting there. Okay, so I'll try and trace it as good as I can. That one is our sine 2x, okay? So that's what happened is I'm just going to start changing a few colors, okay? But for the moment, that sine 2x just represents that every single value is being multiplied by 2. Okay, so every single value, so its maximum location is 2. But what you notice is when the values are 0, those times don't change. Okay, so that hasn't affected our period at all. So it's still 0 at 0 degrees, it's still 0 at pi, and it's still 0 at 2 pi. Okay, so those 3 locations have not been affected. What's happened is this is our dilation from the x-axis. Okay. Our 1, so our 1 sign is that standard one in the middle that we've got there. And then if you have a half x, I'm just going to change the color. Half x is our little one. Okay, so that's our little one. But again, as you notice, that the locations of my x-intercepts, okay, it's probably a bit hard to see with the eye, I probably didn't pick a great color. They haven't changed. Okay, the only thing that's changed is our dilation. Okay, so our distance from our x-axis. Okay, and that's just been half, and that's represented by the half sine x at the front. Okay, so as we move across, we get a few different ones. Okay, so as you can see with the color, so if you see with the purple line, so you see the purple line where my sort of if I can find my mouse, yeah, my cursor is sort of tracing around. I might try and get a purple color. Yeah, I'll get purple there. So that purple line, as we're moving away through, okay, that's our standard y equals sine x. Okay, what you notice with that is right there, just after 6, okay, that'll have an x-intercept at 6.14. That 6.14 is actually represented by 2 pi. Okay, so what you're going to have with our sine x, we're going to have a period of 2 pi over 1. Okay, remember it's 2 pi over n, which equals 2 pi. Okay, so that hasn't changed. So we haven't had any dilation from any change in dilation from our y-axis. Okay, so as we go to, I'll change to red. Okay, we've got 2x. Okay, so what we have is our period is actually equal to 2 pi divided by 2. Remember, that's our value of n inside our formula. Okay, that means our period is pi. That means it takes, okay, to complete one full wavelength, that distance right there is pi. Okay, so what you notice with the red, as we go to our graph, our sine graph has actually halved, and it's actually completed one full revolution in pi. Okay, so that distance there is pi, so our full period is pi. So that location right there in the middle will be pi on 2, half that, and these will be broken up into quarters. Okay, but we'll touch on a lot of that later on. But what you notice is that its wavelength was a certain distance, and it's just halved. And that's represented by the 2x. So it doesn't get twice as wide, it gets twice as small. Okay, and that all comes from the divided by n. The same would work for our sine of 3 of x. Okay, period equals 2 pi on 3. So as you notice that my bluish one, it gets even thinner. And then I'll touch on this last one, just a half x. Okay, so if I do 2 pi over 1 on 2, that makes our period actually 4 pi. And that's our big green one. As you can see, our big green one there. Okay, so I'm going to go through a couple of examples in the next video.